Hi everybody, today's video is all about graphing rational functions. But today we're going to graph specific functions that have holes. So there's literally a hole in the graph. So what you're going to notice about these equations is that they're a little bit more complex and you're required to factor them. So for the first step you need to factor. So on the top I have x squared minus 9. That's a difference of squares. So x plus 3, x minus 3. And then in the denominator, since I have that lovely 1 in front, I need two numbers that multiply to -6 and add to -1. So that has to be -3 and +2. So once you factor, what you notice is that you have this factor that cancels, this x minus 3, because you have one on the top and one on the bottom. So that's very important because what that means is you have a hole at 3, because 3 minus 3 would be 0. What x would be? That's 0. So your hole is at 3. So anytime you cancel a factor, so if it's canceled, you have a hole there. So before we finish up that hole, let's write our simplified version. It's x plus 3 over x plus 2. And this is what you're going to use to find everything else pertaining to this problem. So the only thing that we used from earlier is the hole. So now we need to find the y value of the hole, because your hole is always an ordered pair. So I'm going to use this simplified equation and I'm going to plug in x. So y equals 3 plus 3 over 3 plus 2 is 6 over 5, which is about 1.2. You can leave it as a fraction or as a decimal, but you do have to graph it, so sometimes it's easier to have that as a decimal. So that's 3, and then let's say, oh, that's not the right spot. That would be 3 and about 1.2, and that's a hole. So you draw a tiny little circle there. So now the rest of this problem is going to follow from something you've seen before, because we're going to use this simplified version here, which is just like something you've seen before. So we need to find the vertical asymptote. Remember, that's your denominator equal to 0. You're looking for the x value that makes this function undefined. And since you can't divide by 0, you're going to set x plus 2 equal to 0, which means x equals -2. So that's your vertical asymptote. So you're going to draw a dotted line through x equals -2. Then your horizontal asymptote. You have to be careful here. Depending on the type of equation you have, you're going to figure out the horizontal asymptote. So this one's what we call even on top and bottom. You have 1x on top, 1x on the bottom. So you're looking for the coefficients, which is 1 over 1. So y equals 1. And you're going to draw a dotted line at y equals 1. So then we're going to go to the calculator to figure out some other points that we can use to help us get the right shape of our graph. So take a second and take out your calculator and go ahead and open y equals, and you're going to type in the equation, which again you're always using your simplified version. So that's x plus 3 over x plus 2. And it's extremely important that you plug this in correctly. You need to have parentheses x plus 3, because you have to put the whole numerator in parentheses and then the whole denominator. So parentheses x plus 2, and then you're going to go to your table. So right now my vertical asymptote is at -2. I already know that. That's kind of where I start. So I'm going to go to -2. Then I need to pick some other points to help me just make my shape a little bit easier. So I've got -4 and then a half, and -3, 0. Then I've got -1, 2, and 0, 1.5. So remember, these always have two branches. So my first branch is going to start over here. It's at -4.5 and -3, 0. And remember, these asymptotes help me shape my graph too. Then on the other side of my vertical asymptote, I have 1, 2, and 0. Oh, negative 1, 2, sorry. That's why I was a little confused. Negative 1, 2, and 0, 1.5. But here's where you have to be careful. This hole is part of your graph. So your graph needs to go to your hole and through it on the other side. So that hole is definitely part of your graph. Okay, so then the domain and the range. I've got all real numbers except for I have a vertical asymptote at negative 2, so x cannot be negative 2. And I have a hole, and the x value is 3 at that hole. That hole is an undefined spot. The graph doesn't work there. So then the range, I've got my horizontal asymptote at y is 1, so y can't be 1. And then at my hole, my y value is 1.2. So it's very important that when you have a hole, you include that in your domain and range. Alrighty, so that's your first example on a rational equation with a hole, and if you need to, make sure that you re-watch it so you're ready to go for class time. Alrighty, so number 2 is another example where we need to factor, and you can look at it because we have 2 quadratic equations in our original function. So the top is a difference of squares, so x plus 4, x minus 4, and then I need to factor the denominator. So that becomes x minus 4 and x minus 3, and you'll notice that you have an x minus 4 on top and bottom. So I know I have a hole and the x value is 4 because my factor was x minus 4. So my simplified version is x plus 4 over x minus 3, and that's what I'm going to use from here on out. So first for my hole, I'm going to plug in x for my simplified version and then find y. So that's 4 plus 4 over 4 minus 3, which is 8 over 1. So at 4, 8. So I'm going to make my hole at 4, 8. And I'm always going to remember that's part of my graph. Okay, so my vertical asymptote. Then I need to set my denominator equal to 0, right? And then solve for x. So x equals 3. So you make your vertical asymptote at 3. Then your horizontal asymptote, again, you need to look at the type of equation that you have. Here I have an x on top and an x on bottom, so I'm looking at the coefficients. So that becomes y equals 1. So that's a horizontal line at y equals 1. And then I need to make my graph. So I need an xy table to help me out. And again, my vertical asymptote is at 3, so I already know I'm going to get an error, and my branches need to be on both sides. So go ahead and take out your calculator and go to y equals, and this time we're going to have x plus 4 over x minus 3. I'm going to go to my table, and I'm going to start with where that vertical asymptote is so I can know I can have branches on both sides. So on the left side, I'm going to have 2, negative 6, and 1, negative 2.5. And then on the other side, we do have to be careful here because you'll notice that it gives me 4, 8. But I already have that as my hole, so I'm not going to use that same point. So I'm going to use 5, 4.5, and maybe one more at 7 and 2.75. So here's enough points that we're going to make a really good graph. So 1, negative 2.5, and 2, negative 6. So again, you know that your branches are also shaped by your asymptotes. So draw those in. Then on the other side, I have 5, 4.5, and 7, 2.75. But also, do not forget that your graph must go through your hole as well, and then head towards your asymptote. And that's it. And remember, you can always go to your graph and make sure yours looks okay. Oops, not a good zoom. I'm going to go zoom 6. And it looks like we did do a good job. So for our domain, I've got all real numbers. X cannot be 3 because of the vertical asymptote, and X cannot be 4 because of the whole. Similarly, the range is all real numbers except for, at my horizontal asymptote, Y cannot be 1, and because of my whole, Y cannot be 8. Okay, so let's do a quick summary so you have all this really important information in one spot. So here are all the steps to help you graph, so make sure you read through those. To find your vertical asymptote, you need to set the denominator equal to 0 and solve for x. For your horizontal asymptote, you have two different situations. We have where it's equal degrees, so there's 1x on top and 1x on the bottom. Your horizontal asymptote is a over c. And then this one is what we call bottom heavy. So you have just x on the bottom, and you have this hanger outer over here, and that is your horizontal asymptote, y equals k. So you have to look to see what you have. And then lastly, for domain and range, your domain is all real numbers except the vertical asymptote and the x value of the whole. And your range is all real numbers except for the horizontal asymptote and the y value of the whole. So again, make sure that you're watching this enough times and closely so you know what's expected of you. And if you have any questions, make sure you write them down on your note sheet so you don't forget to ask in class. See you later.